All right, so today's lesson we're going to talk about kind of the history of modern chemistry. When did it start? You've probably seen Disney movies such as Aladdin, and they have alchemists. They have these magician-like figures that make smoke and do this. That was around the time, say 1400 to 1700. They knew compounds existed. They knew there were things that could create smoke and make fire and make explosions, but they didn't understand the process behind it. It was still a pretty dark age. They could make it happen, but they didn't know why it happened. And it wasn't until the 18th century that this started to change. And in 1808, a man by the name of John Dalton, he was a humble school teacher, teaching in a one-room schoolhouse in England. He came up with some interesting ideas, and these later became known as Dalton's atomic theory, and they are the main ideas that are the foundation for modern chemistry. So for the last 200 years, these things have been proven true over and over and over again. And we're going to look on the next slide at what some of these are. But keep in mind that at this point, scientists still had very little to go on. The periodic table, which is a way to organize all the elements, the things that make up nature, hasn't been developed yet. So John Dalton comes around, and in 1808, he comes up with his atomic theory. So let's take a look at it. Dalton's atomic theory said 5 things. These are 5 very simple things, and they seem obvious to us now. If we could go back in time, this could be named Held's atomic theory, and I'd be very happy about that, but unfortunately I wasn't around. But you have to also remember that the amount of knowledge back then was a fraction of what it is now. So this was a huge and controversial set of statements, yet it has proven true over time, and it's been vindicated, and Dalton's been vindicated. So the first one is this. It's that elements are made of tiny particles called atoms. So we talked in the last video about elements, and those atoms are the building blocks of everything that exists on Earth. Every gas, liquid, and solid is made up of atoms. He also said that all atoms of a given element are identical. So if I have a piece of gold, so I'm going to draw down here. Here's a chunk, and this is. So we talked in the last video about symbols. The symbol for gold is AU. So a joke I like to tell my kids: what did the 2 chunks of gold? What did one chunk of gold say to the other chunk of gold when it saw him? AU. Get it? Okay. Anyways, all the atoms of a given element are identical. So in this chunk of gold, there are billions and billions and billions of atoms. More than billions and billions and billions. Just a countless number. Yet every single one of them, if you were to reach in, if you could imagine, you could reach in and pick any atom out, would be exactly the same. The third thing is that atoms of a given element are different from those of any other element. So if we have our gold here, so let's make this gold colored. Here's our 2 chunks of gold. And let's draw. Here's a chunk of silver. The particles that make up this silver are atoms. The particles that make up the gold are atoms. But the 2 atoms of each substance are different from each other. All the atoms here are the same. All the atoms here are the same. But compared to each other, the atoms here are different than the atoms here. And that was Dalton's third point. The fourth one, atoms of one element can combine with atoms of other elements to form compounds. And that once that happens, the atoms have that compound will always have the same relative number and types of atoms. So let's take a look at the next slide. And here is John Dalton. He's thinking about what will he eat for dinner that night, or maybe he's thinking about his atomic theory. We're not sure at that moment when that picture was taken what he's thinking about. But we look here, and we have pictures of 3 these are drawings, these aren't pictures. You cannot take a picture of an atom. But these are pictures of 3 compounds. This one, nitrogen oxide, or mononitrogen monoxide, nitrogen dioxide, and dinitrogen monoxide. Now, interestingly, this compound is known as laughing gas, and it's one of the chemicals that it's a drug that if you take it, you just start laughing uncontrollably, and it was used by dentists for quite a long time. And in fact, early scientists, including Dalton, used to use this drug in their lab once everybody had left. It was kind of a fun time, good time molecule, good time particle. Not used like that anymore. Other drugs have surpassed it now for that purpose. But Dalton's fourth statement can be seen here in this picture, is that here we have an atom of nitrogen, here we have an atom of oxygen. In this molecule, nitrogen monoxide, it's 1 nitrogen and 1 oxygen. So if we go down here, NO is 1 nitrogen and 1 oxygen. All particles, all particles of NO, of nitrogen monoxide, will always be 1 N and 1 O. All particles of N2O will always have 2 N's and 1 O. So it's kind of like if you take a drink of water, you know water is H2O. You can be assured that every particle that goes flying down your throat and into your stomach to quench your thirst, every particle of that substance that is water will have 2 H's and 1 O. And that is the law of definite or constant composition. So that is Dalton's atomic theory. And we will, in the next video, take a look about how exactly do we write. We know now the symbols of the elements. How do we exactly write the formula for these compounds?